This is the question from additional exercise, page 140, question number 7. Given a water molecule consists of one oxygen atom and two hydrogen atoms. Oxygen atom has the magnitude of charge, if you look at here, negative, mean this one is a negative charge, and each hydrogen atom has magnitude of charge positive, mean these two are positive charge. Distance between oxygen and hydrogen atom given this. We are asked to sketch a diagram of forces acting on, if you look at here, you should highlight this one, oxygen atom. So in order to draw the force diagram, first of all, for us to easier label the atom, I denote this one as Q1, Q2 and Q3. So I draw here this one Q1, Q2 and Q3. I actually should draw this nice, so I draw it again. I should start to draw the arrow from oxygen atom. So you never draw an arrow which is start from hydrogen, because in this case what they want us to show the force acting on oxygen atom, means the arrow should start from oxygen, not hydrogen. So if you draw like that, okay, and if you label the force, and so this one wrong, should start from here. So what is your answer for this one? Negative, positive. This atom will be attracted towards positive charge, so I have F. And then I should label this one Q1, Q2 and Q3, so this one will be F. This one is the force from Q3 on to, so on where? On oxygen atom, means on charge on Q2, so the 2 should at the behind, and this labeling should be consistent. Consistent means this one positive, negative. So same thing here, being attracted, okay, towards Q1. So this one will be the force from Q1 on to, okay. Kalau dengan sini on Q2, so 2 should be at the behind. This one also at behind, so this labeling should be consistent. So here will be the answer for 7A. And how about 7B? 7B, in order to find magnitude of the resultant force. So what we're going to do for this one, first we have to find what is the magnitude of F12 first. So this would be K Q1 Q2 over R12, and don't forget square, right? And you also have to find what is the value for F32. So it would be K Q3 Q2 over R squared. So this one will be your answer. Okay. Next, what else do we have? If you look at here, substitution. We do substitution on this one. Q1, what is the value? 1 power of negative 10. Q2, which is negative, but remember, we never substitute the sign of the charge for the force. So this one 1.1 power negative 19, and the distance between Q1 Q2 is actually 1 power of negative 10 squared. So this one's also the same. You substitute. What is Q3? Q3 okay. So here I do a mistake here. For Q1, the magnitude for the Q1, this one should be 0.6. 0.6. Okay. Nilai Q1 ni sepatutnya dengan nilai ni. So Q3 also 0.6 power of negative 19, and this one 1.1 power of negative 19. How about the distance between them? 1 power of negative 10 squared. Okay? By using calculator, try to calculate this. And what is the answer? You found that the substitution for these two values, okay, all the value for these two forces are exactly the same, which is, how much is that? You found that this one 5.94 power negative 9 Newton. This one also same. But in order to find resultant force, can I add on these two together? Cannot. Why? Because it's not along the same axis. This is not x or y axis. This is not along x. It's not along y axis also. So what do we do? These two forces, both also you have to do resolving. You have to resolve the forces. Okay. So how you're going to resolve the forces? Okay. For example, as I told you before, if I redraw the vector, same direction, same length, then I can say these two vectors are the same. So how are we going to do resolving? So remember, ini fx dia, mana fy dia, ini fy kita. Okay, ini fy kita. Dan kita perlu tahu sudut ni berapa. So how I'm going to know the angle? I'm going to know the angle. So what do we do? If you look at here, okay, according to the diagram here, you can actually draw a straight line here. Going in straight line, the angle for a straight line is actually 180 degree. Okay. Yang kita tahu adalah theta ini kan dengan theta ini kan. Sudut ini adalah sama kan. Okay. So this one is the angle for straight line. Straight line. Angle for a straight line. So total angle for straight line saya dapati theta tambah theta 2 theta tambah lagi dengan 108. Kalau saya jumlahkan, is actually equals to 180 degree, right? Okay. And if you calculate from here, macam mana kira 2 theta sama dengan ini pindah ke kanan. Okay. Kalau you cari theta, you dapat 30. Okay. Sorry, 36. 36. And kalau you ada nilai theta, iaitu nilai theta sama dengan 36. Now we can do resolving already. How you going to resolve a vector? Make them always put them in table. Okay, so for example, how many forces that we have? These two. Okay, how many components that I have? 2. This one F32, right? Okay, kita tengok F32. Memandangkan sudut yang saya ada adalah lebih dekat dengan komponen X, I use the shortcut. So to find the value for the component X, I use cos angle for the component X. Cos 36 yang darab dengan 5.94 power negative 9. Okay, so why we didn't substitute Q2 with the negative sign? Because for information, negative sign for the force actually indicate the direction for the force. Okay, so here we will decide the direction for the force from resolving vector here. You see, Fx towards right. Force ini, Fx ini ke kanan kan, ke kanan, positif kan. Okay, kita akan tentukan sign dengan tengok arah ini, arah force ini. Okay, so never substitute the magnitude of the sign here. And then how about this? For y component, so I will use sine 36 degree for y component times with the magnitude of F32. Force ini ke atas kan, positive. Alright, how about F12? Okay, so for F12, if I draw a vector which is same direction, same length, so I can say this one F12 as well. Alright, and then if I do resolving, this one Fx and this one Fy. Fx, we have already have the angle which is nearer to the x component, right? So this one cos 36 also, times with the value of F12 5.94 power negative 9. Okay, how about this one? This one sine 36 times with 5.94 power negative power negative 9 here, right? Jadi di sini baru kita cari total Fx, yaitu ini. Okay, tapi sebelum itu saya perlu tentukan sign. Ini ke kiri kan? Okay, Fx ini ke kiri, so put minus sign for it. Upwards, so this one positive. In x component baru tambah dengan x component. Okay, kalau ditambah dia dapat kosong. Macam mana total Fy? Ini tambah ini. Alright, jadi ini jawapan yang kamu sepatutnya dapat. Next, how you are going to find what we call the magnitude. Adakah ini jawapan akhir untuk magnitude kamu? Bukan. Okay, kalau kamu buat sampai sini, untuk kita cari magnitude, kita guna teorem Pythagoras kan. Okay, jadi kalau you kira kosong nimbung ganti, and you get this answer. How about the direction? If you have no idea about the direction, okay, so one of the traditional way will be kita cari sudut kan. Okay, jadi untuk ini 6.98 power negatif 9 bahagi kosong kan. Ini kalau you kira, you dapat infinity. Okay, then kalau you inverse tangent kan infinity, so what do you get? You get 0. Sorry, you get 90 degree. You get 90 degree. 90 degree means what? 90 degree, okay, you try to draw 90 degree. This one is a 4 quadrant here. 90 degree means positive. 90 degree means start from here. Here always our reference axis. Start from here, dia rotate. Kalau positive, dia rotate anti-clockwise. Okay, sebanyak 90 degree maksudnya vektor, resultant vector arah kita atau resultant vector kita untuk case ini somewhere here. 90 degree means somewhere here, exactly along y-axis. Okay, how I'm going to, so ini obviously upwards, right? So the direction for this one, I should state actually upwards. Why? Kenapa upwards? Okay, sebab kalau ini 90 degree, maksudnya resultant vector di antara ini dengan ini sepatutnya, okay, along y-axis. Alright, jadi ini jawapannya, upwards. Okay, so this one is a value for your force and this one will be the direction.